Today we're going to talk about covalent bonding. Covalent bonds are formed when nonmetals share pairs of electrons. Remember, they share to have an octet to become stable. Single bonds consist of two shared pairs of electrons, or one pair, two shared electrons, or one pair. A double bond consists of four shared electrons, or two pairs. And a triple bond consists of 6 electrons, or 3 pairs. Formation of covalent bonds are formed both by the repulsion and attraction between the nucleus, the positive nucleus of two atoms, and the electrons. So remember, opposites attract, so you have an attraction due to the positive negative nature of protons and electrons, and you have also a repulsion. So these covalent bonds are formed when the orbitals overlap, whereas in ionic compounds the orbitals are separate. And then these electrons will spend time in each other's orbitals around whatever type of atom it is. So these two electrons then will help make up the octet that it needs. So properties of ionic covalent compounds are: ionic compounds are typically metal-metal or a metal-nonmetal, whereas covalents are between two nonmetals. Ionic compounds have a total transfer of electrons between the orbitals, where you have overlapping orbitals and shared electrons in covalent compounds. Ionic compounds have very high melting and boiling points, whereas covalent compounds tend to be liquids at room temperature and have very low melting points. Solids at room temperature for ionic compounds. Ionic compounds are very hard and brittle, whereas organic compounds are very soft. The bonds between the metals and the nonmetals of an ionic compound are very strong, whereas those in a covalent bond are very weak. Ionic compounds are very electrically reactive, and covalent compounds typically do not conduct electricity. Ionic compounds are very soluble in water because water itself is polar. We'll talk about that later. And covalent compounds tend to be insoluble, so think about like oil in water, and oil is covalent. And then this is important: the electron orbitals are separate in ionic compounds, and the orbitals overlap in covalent compounds. So let's practice identifying based on what the compounds are made of. So you can pause and think about it if you need to. So remember, on your periodic table you have both metals and nonmetals on that stair-step line, and that's how you tell the difference between ionic and covalent, because ionic contains metal and a nonmetal, covalent contains two nonmetals, and the subscripts for the formulas don't affect that at all. So the first compound, carbon dioxide, which do you think it is? Did you say covalent? You are correct. What about number 2, water? Ionic or covalent? Covalent. Number 3, sodium chloride. Ionic or covalent? Ionic. Hydrosulfuric acid. Number 4. Ionic or covalent? Covalent. Sulfuric acid. Number 5. Ionic or covalent? Covalent. Calcium chloride. Ionic or covalent? Ionic. Silver 2 bromide. Ionic. And number 8, dinitrogen trioxide is covalent. So if we look, carbon is nonmetal, oxygen is nonmetal, so that's covalent. Hydrogen, even though it's in group 1 in the alkali metal group, is a group by itself, and it is also a nonmetal, and oxygen's a nonmetal, so it's covalent. Sodium chloride's in group 1, chlorine is in group 7, so it's a metal and a nonmetal, makes it ionic. Hydrogen, again, in a group by itself, over there in group 1, is a nonmetal, with sulfur is also a nonmetal. Hydrogen, sulfur, and oxygen are all 3 nonmetals, so therefore it's covalent. Calcium is in group 2, it's a metal. Chlorine is group 17, so it's a nonmetal, so it's ionic. Silver is a transition metal. Bromine is a group 17 nonmetal, so it's ionic. Nitrogen is a nonmetal in group 15, and oxygen is a nonmetal in group 16, so it's covalent.